So if you draw the diagram to this, the diagram will look like this. You have a convex lens, you have another convex lens, and you have a convex mirror. Okay, this distance is 30 centimeter. The object is placed in this place 30 centimeter. The convex lens is placed at a distance d from the second lens B, and it said that the position of the final image coincides in position with the object. So I have to find this distance d. A hint to this question is, first of all, try thinking in terms of the principle of reversibility. And the second hint is that there is no shift in the position of the image when the object is placed at pole and if the object is placed at the radius of curvature. When the object is placed in these two positions, then there is no shift in the position of the image and the image is formed at the same position as the object. Okay, try thinking in terms of these 2 points. These are the hints. Okay, so now let's see how to solve this question. In this question, how do you proceed? Well, you see that here the focal length is given as 20 for both the convex and for both the convex lens. Okay, one thing is for sure that if this is the image, this will form some intermediate image. Since the focal length is 20, so that means the object is placed within the focus and the center of curvature. So my image will be formed somewhere here, somewhere this side. Let's see where the image is formed by the first mirror, by the first lens. 1 by u plus 1 by v is equal to 1 by f. What is u? U is 30 and it's positive. So this forms an image at a distance of 60 centimeter. That means here, this is the intermediate position of the image. Now let's see where this lens forms an image. So let's see where this one forms an image. To find that, we'll again use the formula, which is 1 by u plus 1 by v is equal to 1 by f. What is u in this case? To move from the object to the lens, I will move in this direction, the incident ray is in this direction. So u is negative, and which is equal to minus 30. Plus 1 by v is equal to minus 1 by 20. Okay? Okay. So my v is what is my v? The focal length in this case is positive actually, because it's a convex lens. So this becomes minus 3 minus 2 divided by 60, that is minus 5 by 60, or v is, sorry, this is positive, So V is 12 centimeter. So this convex lens forms an image 12 centimeter from the second convex lens. So this is the position of the final image formed by this lens. Now, if I apply principle of reversibility, then if this would have been my object, then this would have formed an image I1, and now for this lens, this would have acted as the object and this would have formed an image at O. Now, but what is happening here? The convex lens forms an image at a distance of 12 centimeter from here. Now, this image formed by the convex lens acts as the object for the convex mirror. So let's say that this convex mirror forms an image at some location this. Now, this acts as the object for this convex lens. So this will form an image somewhere here, let's say, and now this acts as the object for this convex lens, so it will form an image at some position here. So that means what? That if there is a shift of the position of this image IF, then there is a shift in position of this final image. Because using the principle of reversibility, I know that for every position of the image, there is one position of the object. The object position and the image position are correlated for a particular reflection or refraction. So if this has to, if after all the reflections and refraction, if I need to have the image at the same position, then what should happen? This mirror should form the image at the same location, such that for this lens, the object is now IF and the image is now II. And for this lens, the object is now II and the image is now at I. So that means what? That the convex mirror should not contribute to any shift in the position of the image. So for this convex mirror, if the object is at this position, the image should be also at this position. So when does that happen? That happens when the convex mirror has its object at its radius of curvature or at its pole. So that means this IF should be formed at either its pole, or the position IF should be either the radius of curvature. So when this position IF is at this pole, that means this distance 12 centimeter is the distance D, and when the position IF is the radius of curvature, this is the radius of curvature, right? And this distance, this image is formed here. So what is D now? D is this distance, which is equal to, this whole is 12. So 12 minus radius of curvature is 7. So D is 5 centimeter. So D is equal to 12 centimeter or 5 centimeter. Now we move on to the third question.